Good day viewers, in this episode, we shall revisit the scaling problem we identified in episode 67, whereby we proposed that the benchtop model built by Barry Castillio was constructed to half scale. Paul Edmund Potter states very clearly in his book titled Gravitational Manipulation of Domed Craft, that Castillio had built the benchtop antimatter reactor, utilized by Bob Lazar at S4. Please refer to section 12.3 on page 365 for the exact quotation. So then, an open question exists with respect to the scale that Barry Castillio's benchtop model was constructed, that is, was it constructed to half scale or full scale? Moreover, we have confirmed that Bob Lazar's demonstration model was constructed to half scale. Therefore, doesn't it make sense that whomever constructed the demonstration model to half scale, did so because they were replicating a half-scale model they saw or knew about at S4? A full-scale model is neither cumbersome nor difficult to transport, so why would one build a half-scale model for demonstration purposes, rather than a full-scale model? It appears that Bob Lazar has introduced confusion to the question of scale, because he presented the half-scale model to audiences, without clarifying the fact that the primary wedge demonstrated does not represent 223 grams. He neglected to mention that the 223-gram primary wedge mass related specifically to a full-scale model, not a half-scale demonstration model. As you can imagine, this leads to great confusion. At half-scale, the primary wedge Lazar demonstrates could only have been 55.75 grams, that is, only 1/4 of the mass of a full-scale primary wedge. In addition to this, the scaling problem is compounded by the fact that the mass density of the primary wedge Bob Lazar endorses, that is, 31.5 grams per centimeter cubed, simply cannot be the mass density of element 115. In other words, whatever material the primary wedge consisted of, must have been some other element, possibly element 247. Please refer to episode 106 for more information. The primary wedge dimensional results we derive in this episode are an astonishing agreement with the dimensions provided to us by Bob Lazar, via Project Gravitor leadership. Therefore, our electrogravimagnetic construct has validated Bob Lazar's dimensional claims, with respect to the primary wedge. We have established that the electrogravimagnetic construct correctly determines the gravity A wave fundamental frequency and wavelength, the gravity B wave frequency, and the precise dimensions of the primary wedge. Our determination of all of these metrics have been indirectly confirmed by Bob Lazar. Hence, we have demonstrated beyond reasonable doubt that we have a solid grasp of the physics associated with the sports model alien spacecraft. We showed in episode 67, as well as this episode, that substantial incentive exists for research engineers to utilize half-scale models. Thus, given that we have a confirmed understanding of the physics associated with the sports model spacecraft, we insist that constructing a half-scale model of an antimatter reactor is entirely possible, and it is not limited by our understanding of the physics involved. If there are any limitations at all, they will be associated with our knowledge of alien materials science, not the physics associated with the propulsion system. Thus, in the absence of any limiting reasons associated with the antimatter reactor materials of construction, we insist that Barry Castillio could have constructed a benchtop half-scale model of an antimatter reactor, utilizing conventional materials. In other words, we insist that the antimatter reactor did not require space alien materials, rather, conventional materials could have been utilized. However, we assert that, if indeed the benchtop model utilized by Barry Castillio and Bob Lazar was at full scale, then we suggest that this occurred because it was simply easier to remove an existing antimatter reactor assembly from another spacecraft, as opposed to fabricating a half-scale model. Okay, let's jump into the investigation. The journey begins with a review of our Element 115 YouTube playlist. The associated episodes contain important information going forward, so if you have the time, please review all the episodes specified in the playlist. However, for the sake of brevity, we have summarized each episode, as appears on screen. Episode 52 establishes that Bob Lazar could not have utilized a primary wedge solution manufactured from 16 discs. The mass constraint of 223 grams means that the mass density of element 115 would need to be 12.63 grams per centimeter cubed. This represents a deviation from the Burkhardt-Frick estimate of 13.5 grams per centimeter cubed. Episode 54 conjectures an explanation for the propagation method associated with the gravity A wave. Episode 57 conjectures that element 115 acts as a quantum vacuum inhibitor, which suppresses the Casimir effect. Hence, by suppressing the Casimir effect, space-time curvature is also suppressed. Storti argues that the Casimir effect varies with respect to gravitational environments. Please refer to the Storti 2011 publication, The Extraterrestrial Casimir Effect. Episode 58 conjectures that a stable isotope of element 115 exists with an atomic weight between 296 and 301. Episode 59 examines the primary wedge manufacturing process by comparing the 12-disc solution proposed by Ken Wright and the 16-disc solution proposed by the electrogravimagnetic construct. In doing so, we treat Ken Wright's 12-disc solution as an optimal configuration, not simply the electrogravimagnetic optimal configuration cut down to 12 discs. We demonstrate that a 12-disc solution does not significantly depart from a 16-disc solution. Moreover, we conclude that whether or not an element 115 cylinder illustration depicts 12 or 16 discs, doesn't matter too much. Episode 60 demonstrates that the sports model configuration researched and compiled by Emeritus Professor Paul Edmund Potter aligns astonishingly well with the optimal 16-disc element 115 solution derived via the electrogravimagnetic construct. Episode 61 presents derivational evidence, reinforcing the episode 58 proposition that a stable isotope of element 115 exists with an atomic weight of 296. Moreover, we conjecture that a stable isotope of element 115 may exist with an atomic weight of 258. However, we stress that the isotope 258 solution is unlikely to be stable. Episode 63 combines the optimal 16-disc element 115 cylinder solution derived via the electrogravimagnetic construct, with Potter's sports model configuration. Episode 64 executes a deep dive into Potter's book titled, Gravitational Manipulation of Domed Craft. We extract important information regarding the minimum number of element 115 disks likely to have been utilized by Bob Lazar. Potter obtained this information via testimonial transcripts from Bob Lazar interviews. Notably, Potter states that a minimum of 12 disks should be utilized in order to effectively amplify the gravity A wave. Episode 65 involves role-playing a potential reverse engineering report scenario, which may have been delivered to an S4 supervisor, by key actors, possibly Bob Lazar or Barry Castillio. Episode 67 considers the role played by Barry Castillio in the Lazar story, whilst including and combining the contributions of Seton Ball, Ken Wright and Emeritus Professor Paul Edmund Potter. This episode emphasizes that a benchtop model scaling problem exists, introduced by the standard nuclear physics theory mass density estimate, derived by Emeritus Professor Burkhard Frick from the University of Kassel in Germany. This means that the Potter and Ball depiction of the primary wedge is a half-scale representation because the base radius is at half-scale. Moreover, we conclude that the benchtop model displayed on Ken Wright's website has been constructed to somewhere between half-scale to one-third scale. Therefore, we may reasonably assume that the benchtop model of the element 115 reactor developed by Barry Castillio must have been constructed between half-scale to one-third scale. The most obvious and convenient possibility is half-scale. It is also important to note that Ken Wright asserts that the element 115 reactor benchtop model he displays on his website belonged to Bob Lazar, not himself. Evidence for this claim can be found on the Seton Ball and Ken Wright websites. Episode 91 involves a brief discussion regarding the peer review of the Lore of Robert Lazar research article, executed by a scientist from the University of Dublin, specifically, Trinity College, School of Physics. Key takeaways from the Element 115 playlist relevant to this episode are as follows. Number 1. Bob Lazar could not have utilized a primary wedge solution manufactured from 16 disks. Number 2. The sports model configuration researched and compiled by Emeritus Professor Paul Edmund Potter aligns astonishingly well with the 16-disc solution derived via the electrogravimetric construct. Number 3. Emeritus Professor Paul Edmund Potter states that a minimum of 12 discs should be utilized in order to effectively amplify the gravity A wave. Potter obtained this information via testimonial transcripts from Bob Lazar interviews. Number 4. A benchtop model scaling problem exists, introduced by the standard nuclear physics theory mass density estimate derived by Burkhard Frick. This means that the Potter and Ball depiction of the primary wedge is a half-scale representation because the base radius is at half-scale. Moreover, the benchtop model displayed on Ken Wright's website has been constructed to somewhere between half-scale to one-third scale. Therefore, we may reasonably assume that the benchtop model of the Element 115 reactor developed by Barry Castillio must have been constructed at half-scale. Number 5. Ken Wright asserts that the Element 115 reactor benchtop model he displays on his website is owned by Bob Lazar. By implication, this infers that the model is a replica of a half-scale to one-third scale model constructed by Barry Castillio. The most obvious and convenient possibility is half-scale. Thus, if Bob Lazar owned the reactor model appearing in the photographs, we may reasonably assume that it was constructed at half-scale, because that is what he utilized at S4. Why would Lazar utilize a half-scale model if a full-scale model is not difficult to produce, nor is it inconveniently large? In order to create the video playlist we just ran through, we assessed 3 primary resources, that is, Ken Wright, Ball and Paul Edmund Potter. All 3 of these resources orbit Bob Lazar, and information flowed directly or indirectly to each one, as appears in the illustration. Our video playlist establishes that the benchtop model displayed by Ken Wright is somewhere between half-scale to one-third scale, so let's quickly run the numbers through calculators 3 and 4 in our spreadsheet. Please refer to the link at the top of the screen to access the spreadsheet calculator and episode 107 for user instructions. Ken Wright states that the diameter of the Element 115 pellet is about the size of a 50-cent piece. Thus, we shall execute the following 6 assumptions. Number 1. We assume that Ken Wright is referring to a US coin, and it denotes the base length of the primary wedge, hence, its diameter is 30.61 millimeters. Number 2. We assume that the thickness of the primary wedge is equal to the thickness of each Element 115 disc, utilized in the primary wedge manufacturing process. Number 3. We assume that the thickness of each disc is equal to 1/4 of the gravity A wave, fundamental wavelength. That is, 6.55 millimeters. Number 4. We assume that the mass density of Element 115 is equal to the Burkhard-Frick value of 13.5 grams per centimeter cubed. Number 5. Given that Ken Wright's benchtop model is between half-scale to one-third scale, we shall assume that the primary wedge height to base length ratio is 2.5, that is, we will sit in the middle of the expected scaling range. Number 6. We assume that the volume of the primary wedge may be usefully approximated to a triangular prism for convenience. In this regard, it should be noted that the volumetric similarity between a triangular prism approximation and its true value is greater than 98.12%. Hence, the volumetric approximation error of less than 1.88% may be disregarded. Once the data has been entered into the spreadsheet calculator, we obtain a primary wedge mass of approximately 104 grams. Unfortunately, this is only about half of the 223 grams stipulated by Bob Lazar. Therefore, it is very apparent that we have some sort of scaling problem. However, it should be noted that we obtain a value of approximately 12 Element 115 discs, in agreement with the number of discs purported by Ken Wright, Ball and Paul Edmund Potter. But before we draw any firm conclusions, let's run another scenario through our spreadsheet calculator. In this scenario, we input the mass density of Element 115 as being approximately 31.5 grams per centimeter cubed. This value of mass density is consistent with information found on the Ball and Ken Wright websites, as well as Lazar.com. However, please note that we have kept the disc diameter, disc thickness and primary wedge height to base length ratio constant. The two important outputs to observe are the number of discs, which is approximately 12, and the primary wedge mass. The primary wedge mass solution returned by the spreadsheet calculator is approximately 241 grams. This is within approximately 8% of the required 223 gram value. Thus, the solution implies that no scaling problem exists. In fact, it implies that the Ken-Wright model was constructed at a 1-to-1 scale. However, in episode 45 at time index 2534, Bob Lazar states that his benchtop model reactor is constructed to half scale. So the obvious question now becomes, which scale does the 223 gram primary wedge mass belong to? A half-scale model, or a full-scale model? As it stands, there appears to be a scaling problem due to the mass density of element 115. Let's take a look at another scenario to see if we can figure things out. In scenario 3, we uphold the half-scale model conception by setting the disk diameter equal to the gravity A wave fundamental wavelength, as derived via the electrogravity-magnetic construct. Moreover, we also utilize the value of disk thickness associated with the optimal 16-disk solution, as derived via the electrogravity-magnetic construct. In addition, we utilize the Burckhardt-Frick value of element 115 mass density. Please note that we have set the primary wedge height to base length ratio to 3. Our results for scenario 3 demonstrate that a 12-disk solution, which is consistent with Ken-Wright, Set and Ball, and Paul Edmund Potter assertions, yields a primary wedge mass of approximately 91 grams. This is almost 60% short of the 223 gram requirement stipulated by Bob Lazar. In scenario 4, we retain the same values of disk diameter and primary wedge height to base length ratio as scenario 3, but utilize a slight increase in disk thickness. Moreover, we set the element 115 mass density to the value asserted by Ken-Wright and Set and Ball, which has been endorsed by Bob Lazar, as appears on BobLazar.com. Our results for scenario 4 demonstrate that a 12-disk solution, which is consistent with Ken-Wright, Set and Ball, and Paul Edmund Potter assertions, yields a primary wedge mass of 223 grams. So as we can see, a half-scale model can be shown to yield the required primary wedge mass of 223 grams, but only if the element 115 mass density is extremely high, and well beyond the standard scientific value derived by Burckhardt-Frick of Kassel University in Germany. Thus, by the results displayed on screen, we have an obvious scaling problem. We still need an answer to the following question, that is, did Bob Lazar measure a 223 gram primary wedge from a half-scale model, or was it a full-scale model? As stated on slides 3 and 4, we established in episode 67, that Ken-Wright's element 115 reactor model was constructed to somewhere between half-scale to one-third scale, and was owned by Bob Lazar. Moreover, in episode 45, at time index 2534, Bob Lazar states that his element 115 reactor model was constructed to half-scale. Thus, by utilizing our own analysis of the element 115 reactor model, combined with Bob Lazar's own statement, we have a reliable scaling benchmark moving forward. This frame is taken from episode 67, and we see 3 pictorial interpretations of the element 115 primary wedge. One illustration originates from Paul Edmund Potter in 2008, the other 2 originate from Set and Ball in 1998. Although these illustrations are separated by 10 years, we have no way of knowing if they are truly independent, or if Potter copied Ball. However, for the purposes of this exercise, we shall assume that they are independently formulated. Unfortunately, neither Potter nor Ball includes dimensional information on their illustrations. This is a seriously limiting obstacle, so we are compelled to overcome it. However, the best we can hope to achieve is a reasonable guesstimate. To facilitate our guesstimate, we have introduced purple dimensioning lines. Once this is complete, we can project the height and base length of the primary wedges, via the red lines appearing on screen. The first thing we'll do, is measure the length of the vertical red line, than the red hypotenuse line. With this information, we can guesstimate the height to base length ratio of the Potter and Ball illustrations. And lastly, we can measure the hypotenuse length of illustration number 1, which Ball claims is drawn to scale. Two very important pieces of information have been obtained via our analysis. Firstly, the height to base length ratio of Lazar's element 115 fuel wedge is approximately equal to 2. And secondly, the guesstimated base length of the element 115 fuel wedge is almost exactly equal to the gravity A wave fundamental wavelength we have derived in previous episodes. This is no small achievement because, don't forget, our gravity A wave fundamental wavelength was derived from particle physics, that is the element 115 nucleus, not from the illustrations appearing on screen. Let's now do a side-by-side comparison of what these illustrations are saying, compared to what we have derived in the previous episodes contained in our Bob Lazar playlist. In this frame, we have taken the Potter illustration and roughly proportioned it in accordance with our element 115 primary wedge manufacturing process diagram. Please remember that, from the previous slide, we have determined that the Potter and Ball illustrations are identical, so it doesn't matter which one we utilize now, it's simply a matter of convenience. Hence, for the moment, the Potter illustration is preferable. What is important to recognize here is that the height to base length ratio is 2 for both diagrams. However, the base length of the Potter fuel wedge is half the base length of the Storti solution appearing on the right-hand side. In other words, the Potter and Ball solutions depict a primary fuel wedge with a base length of 1r, and the Storti solution depicts a base length of 2r. So, the obvious question becomes, who is correct? Well, given that we know the Kenwright element 115 reactor model was owned by Bob Lazar, and was constructed to half scale, we know that the Storti optimal 16-disc solution is correct. Viewers should also understand that the Storti solution allows for variations in the number of discs utilized to manufacture a primary wedge, as illustrated. However, Paul Edmund Potter asserts that a minimum of 12 discs should be utilized. This claim is echoed by the illustrations of the fuel wedge manufacturing process, appearing on Kenwright's website. Let's now look at two full-scale model scenarios utilizing the Storti solution and the electrogravity-magnetic construct. In both of the scenarios appearing on screen, we have utilized the gravity A wave fundamental wavelength derived via the electrogravity-magnetic construct, that is, 26.2 mm, in order to calculate the disk diameter. Hence, as per the previous slide, the disk diameter will be equal to 2r. In other words, the disk diameter equals twice the gravity A wave fundamental wavelength, that is, 52.41 mm. Moreover, we have utilized the same disk thickness for both scenarios, which is 1/4 the gravity A wave fundamental wavelength, that is, 6.55 mm. In addition, we have utilized the same primary wedge height to base length ratio for both scenarios. This ensures that each scenario denotes a 12-disc solution, which is consistent with Set and Ball, Paul Edmund Potter and Kenwright illustrations. Upon inspection of the full-scale model results returned by calculators 3 and 4, in each scenario, we immediately understand that the configuration utilizing the Burckhardt-Frick mass density value of 13.5 grams per centimeter cubed, is substantially closer to the required 223 gram primary wedge mass, than the configuration utilizing the Bob Lazar endorsed mass density value of 31.5 grams per centimeter cubed. Let's now investigate the effect of changing the primary wedge height to base length ratio. In this frame, we utilize scenario 5 and 6 as a foundation to generate scenario 7 and 8, by incorporating modifications to the primary wedge height to base length ratio. Please note that scenario 7 and 8 denote full-scale primary wedges. The term full-scale is defined by disk diameter, that is, being twice the gravity A wave fundamental wavelength, as derived by the electrogravity-magnetic construct. For these new configurations, we have utilized the primary wedge height to base length ratio specified by calculator 4, as our inputs. In doing so, we generate the required 223 grams, but we no longer generate 12-disc solutions. In the case of scenario 7, we generate a quasi-15-disk solution, and in the case of scenario 8, we generate a quasi-6-disk solution. These results demonstrate the significance of the primary wedge height to base length ratio. Let's now take a look at what Project Gravator has to say about the primary wedge. As of the production date of this video presentation, the Project Gravator website displays this image of Bob Lazar holding a primary wedge, with a model of the Element 115 reactor in the foreground. Given that Project Gravator's objective is to accurately reproduce Bob Lazar's story in a visual sense, we may assume that Bob Lazar has endorsed the dimensions of the primary wedge appearing in the image. Hence, this image begs the question, what are the dimensions of the primary wedge? Let's use this image to determine what some of those dimensions might be. By magnifying the image and executing a set of relative measurements within the Apple Keynote environment, we may determine some impressively accurate dimensions. Assuming Stardy's index finger width measurement of 17 mm is acceptably similar to Bob Lazar's index finger, we predict a primary wedge base length of 51 mm. When we compare this estimate to the value appearing on the preceding slide, that is, 52.41 mm, we confirm greater than 97.3% similarity between the base length of the primary wedge being held by Bob Lazar, and the gravity A wave fundamental wavelength predicted via the electrogravity-magnetic construct. Thus, utilizing a primary wedge height to base length ratio of 1.2053, which was determined via relative measurements, we estimate that the height of the primary wedge being held by Bob Lazar is approximately 61.47 mm. Hence, the number of disks utilized to manufacture the primary wedge, as predicted by the electrogravity-magnetic construct, is 9 to 10. Please refer to the simple calculation appearing on screen. The value of disk thickness equaling 6.55 mm is common to all scenarios presented so far. It is important for us to mention and for viewers to appreciate that since establishing our disk estimate, Project Gravator leadership has confirmed via Bob Lazar that the primary wedge consists of 10 disks. So what does this mean? Well, it should be quite obvious. It means that the derivation of the gravity A wave fundamental wavelength, and the derivation of the optimal 16-disk solution via the electrogravity-magnetic construct, has been implicitly validated by Bob Lazar. From Bob Lazar's implicit validation of the electrogravity-magnetic construct, which we proved on the previous slide, we may represent ideal configurations in accordance with episodes 52 and 65. The key design principle on this slide is that the engineering solution is anchored to 1/4 R, that is, 1/4 of the gravity A wave fundamental wavelength. Thus, viewers should notice that the primary wedge thickness equals the disk thickness, which also equals 1/4 R, and in turn, also equals 1/4 of the gravity A wave fundamental wavelength. Moreover, we have provided solutions pertaining to different isotopes of element 115. However, whichever isotope we choose to utilize going forward, doesn't really matter too much. Okay, let's now investigate some, less than ideal, primary wedge solutions. In these two scenarios, we are working with full-scale models, but have shifted away from anchoring all dimensions to 1/4 of the gravity A wave fundamental wavelength. Instead, we have allowed the thickness of the primary wedge to be specified on an ad hoc basis. In doing so, we obtain two configurations for disk thickness which yield a primary wedge mass of 223 grams. One disk thickness result relates to the Burkhardt-Frick value of mass density for element 115 being 13.5 grams per centimeter cubed. The other disk thickness result relates to the value of mass density for element 115, endorsed by Bob Lazar, that is, approximately 31.5 grams per centimeter cubed. The value of disk thickness appearing in scenario 10 agrees to 94% similarity with the Bob Lazar endorsed value revealed to us by Project Gravator leadership. Please remember that the value of disk thickness shown is based upon a triangular prism approximation of the primary wedge, not its geometrically exact volume. Unfortunately, we are unable to share the precise Project Gravator dimensional value revealed to us, due to a governing confidentiality agreement. Before we leave the slide, we will emphasize that the utilization of the electrogravity-magnetic construct in this video presentation validates the primary wedge configuration asserted by Bob Lazar. Okay, let's now investigate a couple more half-scale model scenarios. From these two half-scale model scenarios, we can see that the primary wedge mass is 55.75 grams, not 223 grams. This means that for half-scale models, the amount of element 115 material utilized is 1/4 of the element 115 material required for full-scale models. Hence, significant incentive exists to execute reverse engineering activities utilizing half-scale models. By doing so, we effectively quadruple the existing stockpile of element 115. Thus, the alleged stockpile of 500 pounds of element 115 becomes 2,000 pounds, or in other words, 227 kilograms becomes 907 kilograms. We made this point very clearly in episode 67. Please take the time to review the episode. The position we took in episode 67 was that Barry Castillio constructed a half-scale model which he utilized at S4, not a full-scale model. In fact, it was Paul Edmund Potter which made the claim that Castillio constructed a model, not us. However, the half-scale model assertion is our claim, not Paul Edmund Potter's claim. So then, where does this leave us with respect to the benchtop model utilized by Bob Lazar at S4? Was it a half-scale model, or was it a full-scale model? Well, before we address this question on the preceding slide, please note that the scenario 11 primary wedge thickness value does not agree with the dimensions endorsed by Bob Lazar. This will become an important factor as we move forward, so please keep it in mind. To finalize our position regarding the scaling problem, we will invoke 4 tranches of evidence. Number 1. In episode 45 at time index 2534, Bob Lazar states that his benchtop model reactor is constructed to half-scale. Number 2. Excerpts from Joe Vanninetti's diary. Joe Vanninetti was a colleague of Bob Lazar, and claimed that the half-scale model which Bob Lazar utilized for demonstration purposes, was constructed by himself and others, possibly with the assistance of John Lear and Bob Lazar. Importantly, Joe Vanninetti implies that neither himself, nor Bob Lazar, nor Barry Castillio, had the ability to construct an element 115 reactor utilizing conventional materials. This is an important inference which we will revisit shortly. Number 3. Paul Edmund Potter's book titled, Gravitational Manipulation of Domed Craft, states very clearly that Barry Castillio had built the benchtop element 115 reactor utilized by Bob Lazar at S4. Please refer to section 12.3 on page 365. Number 4. We showed in episode 67, as well as this episode, that substantial incentive exists for research engineers to utilize half-scale models. So then, how do we reconcile the alleged assertions by Joe Vanninetti with the verifiable statement made by Paul Edmund Potter? Joe Vanninetti infers that Barry Castillio could not have constructed a half-scale model of an element 115 reactor, yet Paul Edmund Potter claims that one was built by Barry Castillio prior to Bob Lazar's arrival at S4. So, is there a middle ground? Well, we have established that the electrogravity-magnetic construct correctly determines the gravity A wave fundamental frequency and wavelength, the gravity B wave frequency, and the precise dimensions of the element 115 primary wedge. Our determination of all of these metrics have been indirectly confirmed by Bob Lazar. Hence, we have demonstrated beyond reasonable doubt that we have a solid grasp of the physics associated with the sports model alien spacecraft. Considering this, we claim that constructing a half-scale model of an element 115 reactor is entirely possible, and it is not limited by our understanding of the physics involved. If there are any limitations at all, they will be associated with our knowledge of alien materials science, not the physics associated with the propulsion system. Thus, in the absence of any limiting reasons associated with the element 115 reactor materials of construction, we insist that Barry Castillio could have constructed a benchtop half-scale model of an element 115 reactor, utilizing conventional materials. In other words, we insist that the element 115 reactor did not require space alien materials, rather, conventional materials could have been utilized. if indeed the benchtop model utilized by Barry Castillio and Bob Lazar was at full scale, then we suggest that this occurred because it was simply easier to remove one element 115 reactor assembly from another spacecraft, as opposed to fabricating a half-scale model. Okay, let's now pull together the key points we have covered or discussed. Reducing our video presentation to its essence, we have directly or indirectly established the following 4 points. Number 1. The spreadsheet associated with the link appearing in the top right-hand corner of the screen contains 4 calculators. Calculator 1 is associated with the optimal 16-disk primary wedge solution. Calculator 2 utilizes Calculator 1 as an input, but allows users to compute ad hoc primary wedge solutions. The key design principle embedded into the computational engine associated with calculators 1 and 2 is that the engineering solution is anchored to 1/4 of the gravity A-wave fundamental wavelength. In the case of calculators 3 and 4, this constraint has been removed. However, it should be emphasized that calculators 3 and 4 have been configured utilizing a triangular prism approximation, not a volumetrically exact solution with respect to the primary wedge. Number 2. The primary wedge dimensional results we have derived are in astonishing agreement with the dimensions provided to us by Bob Lazar, via Project Gravitor leadership. Therefore, our electrogravimagnetic construct has validated Bob Lazar's dimensional claims, with respect to the primary wedge. Number 3. We have established that the most likely mass density value associated with the primary wedge is 31.5 grams per centimeter cubed. As per episode 106, we assert that Bob Lazar did not use element 115 at S4, he utilized an alternative element, possibly element 247 instead. Number 4. Given that we have a confirmed understanding of the physics associated with the sports model spacecraft, we insist that constructing a half-scale model of an antimatter reactor is entirely possible. Moreover, we assert that, if indeed the benchtop model utilized by Barry Castillio and Bob Lazar was at full scale, then we suggest that this occurred because it was simply easier to remove an existing antimatter reactor assembly from another spacecraft, as opposed to fabricating a half-scale model. Moreover, an obvious question needs to be asked. That is, if Giovannetti and others fabricated an antimatter reactor at half-scale for Bob Lazar to utilize in demonstrations, doesn't it make sense that they would do this because they were replicating a half-scale model they saw or knew about at S4? Okay, many thanks for your time, we hope you enjoyed the video presentation. If you have any questions or queries, please reach out to me via the email address appearing on the first slide.